Now this figure 20-9 deals with determining the full load current rating of a transformer based upon its voltage and the size of the transformer and so forth. Now, notice in the call out we have the grounded secondary side of that transformer, and we refer you to 240.4F, 240.21C1, and 250.130A and 250.24A. And of course, you know that's the size of the conductors where you're tapping off the secondary side of that transformer where your transformer secondary conductors, so to speak, there. So it is a grounded type transformer because we are grounding one side of that because it's single phase. We could take either side of that transformer, either L1 there or the other side and ground it. Either side grounding would be okay. Now, notice in the quick calc, beginning with 240.4F along with 240.21C1, we have a 2-to-1 ratio. When we take the 480 volt primary and divide it by the 240 volt secondary, we get 2 to 1. So if we had, say, 100 amp on the secondary, we could divide by 2, and that'd give us 50 on the primary. Take 50 amps times 2, that's 100, and you'd come up with 100 amp there, see. Now notice we could use a number 3 THWN copper conductor rated at 100 amps from table 310.16 and the 75-degree column there that we would review. But notice the quick calc, you can also see what we were relating to you to the left of the transformer down at the bottom where it says single phase 2 wire. Then notice it's 240 divided by 480 times 100 would give you 50 amps. It's easier to me to use the ratio, and electricians have told me the same thing. Now, equipment grounds, you could look at 250.130A and 250.122 to size the equipment grounds. But now, if we want, remember this is single phase we're looking at. Now for 3-phase, the quick count would be the same. The tap conductors for secondary transformer conductors would be the same. So quick calcs 1 and 2 would be basically the same that we would be reviewing there. But now to determine what size conductors we would use here, notice we're using 600 kc mills, good for 420. All conductors are copper, selected from table 310.16, and we're selecting those from the 75-degree column because we're not derating in any way. And then notice in the step 1, the application is 240.4F and 240.21C1, and we take 240 divided by 480, and that would give us 420. And when we do the math, times 420, 240 volt divided by 480 volt times 420 would equal 210. So the solution is the overcurrent protection device would be rated at 200 amps for this three-wire system, because we would be protecting the output of the transformer, the conductors, the panel board, the bus board, all would be protected, see. And remember, we can protect the 2-wire by the primary, but you could not protect a 2-wire to 3-wire. So we have a delta and a delta here that we're reviewing. And when I say delta to delta, that's primary to secondary, as you see in the illustration. So this is determining what the currents would be, full load current ratings, based upon the single phase or 3-phase type transformers that we're installing. And that's what this illustration 20 dot 9 is illustrating.